You all are encouraged to work together, compare answers. Hopefully get lots of good agreements. Or discussions work too. Keep at it. Screen for you, and we can discuss those. Got some work up there to go along with, so if you want to check that out, you're welcome to it, and I'll be happy to clarify anything if something does not seem to make sense. Yes, for number 1 was 2, from a final answer perspective. Number 2, 3x squared minus 13x plus 34. The equation of number 3 was x equals negative 1/2. Number 4, you've got your domain and range listed. It is a function because every input has exactly one output. So, questions? What do you have to do to help? You can. Yeah, there's no rule that says you have to do it from large to small or small to large, or it could just be in the order that you saw presented. That's up to you. Yeah. And I just tend to go with the order I see. But if you want to put it in order, it's fine. Sebastian?
For B, in the explanations, it also makes sense to say none of them have 2 outputs.
None of the inputs have 2 outputs?
Yeah.
I think that's pretty good, but then somebody could take that the wrong way, so they could say, oh, so if an input has 3 outputs?
More than.
If you said none of the inputs have more than 1,
Okay.
I could go with that.
Okay.
Yep. Yeah, good question. What else can I do to help? These are really good, insightful questions about just little details that could feel more like a big deal, right? Sometimes the little details can trip you up. Anything else? I hope you're doing great with the equation. I saw a lot of good answers as I walked around, but some of you kind of hovered over your paper. I couldn't exactly see, and I didn't want to disturb your thought process, so I didn't interrupt. But is there anything I can do to help? Okay, fair enough. So we're going to do 2 more things today. The next thing we're going to do is we're going to explore more about lines. And I noticed about 3/4 of you completed the intro video. Bravo, that's better. Means 1/4 of you did not, roughly, give or take a few people. I think, if I remember correctly, in this semester, for the whole rest of the semester, there's either 1 or 2 total intro videos left. And I just want to remind you, intro video is not like an optional if you feel like it or if you just want to. It's something that's expected, right? So that's why it's in there for a grade. Hopefully those that didn't get the opportunity to do that, this will go okay. For those that did, we're talking about what? Lines, yes. Basically lines again and some more specific things about lines. So we're going to do that, and then at the end I'm going to hand back your test to you, and we'll take some time to just review some of the things on there, and then we'll be moving on. So here we go. If you guys could flip forward a couple of pages here to practice 1. Practice 1. So I want to review a couple things just verbally with you from the video. Somewhere in the video, I think I said something along the lines of, in order to graph any line, you only need 2 things. You remember what those 2 things are? And a... Okay, so if you had a y-intercept and if you had an x-intercept, that is enough to graph a line. But that's not going to be the most efficient way, given most of the time the way we see equations written. I think there's maybe a more general way to think about it. Yeah.
Need 2 points.
Okay, and that's the x-intercept and the y-intercept, 2 points, kind of the same thing. But again, we're not going to use a table. To me, like the tables we did last time are good, but they're not the best way. So let's keep going. What do you think, Julia? If you know the slope of the line, now let's think just think descriptively. Isn't a slope essentially how steep the line is?
Yes.
Like I'm a skier. I love to ski. And I snowboarded for a while too. I've skied way more than I've snowboarded, so I ski. That's just what I do. And when I think of a slope like this, I think not very steep, right? I think when I hear the word slope, I think steepness of a ski hill, right?
Mm-hmm.
Steeper, right? Real steep. Probably not going to do it. Right? Boring. Or cross country. Not so boring, but hard work, right? Serious hard work. Yeah. So I think of a ski slope when I hear the word slope. That's really what it is. It's how steep the line is, right? So if I know the slope, that's very helpful. And what's the other thing I need to know? So that's actually true, but it's too specific for me. Okay, I want to be very general here. If I know the slope and one other thing, I bet somebody knows it. That's too specific. You're not wrong. You're definitely not wrong. Okay, now we're getting kind of warmer here, a little bit warmer. If you have an output, what produced the output? An input, yes. And so on a graph, an input and an output show up as what? No, that's slope. And an ordered pair shows up on a graph as? A point. A couple of folks said that. Yes, a point. So I'll write this up here at the top. And we'll try to use this. So if I'm going to graph a line, I need two things. Number one, I need a slope. That's how steep the line is. And number two, I need a point on the line. For the next couple of months, you're probably going to hear me ask you that question over and over and over and over. So you might not have been great at it this morning, but that's all right. We'll keep working at it. So I'm hoping that here in the next days and weeks, if I were to say, what are the two things you got to have to graph a line, you're eventually going to say, I need a slope and a point that's on the line. Make sense? So a lot of you guys said y-intercept when I was asking about you need a slope and what else. A lot of folks said you need a y-intercept or an x-intercept. Isn't it true that y-intercept is a point on the line? Yes. But we don't need to have that point necessarily. I mean, that's good if you know how to do that. But we can use other points as well. And we're going to talk about that a little bit today. Okay, so we're going to start this off, and I'm going to kind of do a little guided practice here with you. I would just like to make sure that you're seeing this and hearing this as best I can show and talk about this one time, and I'll let you do some practicing too. So this says graph using slope-intercept form. If you watch the video, I think you heard that term a couple times, right? Slope-intercept form. Maybe you've had an algebra class in the past where you talked about this. Can anybody explain, or maybe just illustrate, a classic way of seeing slope-intercept form? So no, okay, good. Yeah, Sophia.
Is it y equals mx plus b?
That is the classic way. Yep, that is the classic way. So I'm going to write it up here. Y equals mx plus b. And either from the video or from your past, we know that the m and the b have significance, right? What does the m stand for? Sorry, Chase. The m does not stand for the y-intercept. It's the slope, which is the rise over run. Yeah, so I'll just write this off to the side here. Slope, or m is slope. Oops, and Ellie has said it pretty well a couple times. She said that's the rise over the run. Okay, and then what about the b? What does the b stand for? The y-intercept. So I'm going to come over here and I'm going to say that 0, comma b is the y-intercept. Remember, the y-intercept is a point on the line, and we don't represent a point with just a single number. We represent it with something, comma, something. And so at the start of these, when we're using slope-intercept form, it's kind of a matching game. So what I want you guys to do now, bless you, is turn your attention to the actual equation of the line we're going to graph. I just highlighted it in orange. Can you guys compare the y equals mx plus b to the equation highlighted in orange? Can anybody identify what the m is? Isn't the m 3? Okay, so I'll highlight that here. Can anybody explain how you identified that the m was 3? Julia? The x, how's the x attached to the m? Multiplication, yeah. That's right. So the number multiplied times the x, in this case that's a 3, that's your slope. So I could come down here and I could say my slope is 3. And then a couple of you mentioned the idea of rise over run. So how do I write 3 as a fraction?
3 over 1.
3 over 1. So I'm going to say that my rise over run is 3 over 1. Okay, so then how about the b? What's the b for my situation? Negative 8. There's the b. There's the negative 8. You can see how they're in the same place. The b never has the x multiplied by it. So no matter what the order is, the m is multiplied times the x. The b is a constant. Okay, so then my y-intercept then is? Careful, remember a point is always going to have an x, comma, y, never just a single number.
0.
There it is, 0, comma, negative 8. So let's review. What are the two things you got to have to graph the equation of a line? A point and a slope, or a slope and a point, right? Either way works for me. What do I have up there? I've got a point, it's right here, and I've got a slope, it's right there. I've got both. That means I am ready to graph this line. That make sense? Okay, so perhaps from the video, or maybe from your past experience with math, if I'm going to graph this line based on my point and my slope, do I sketch out the slope before I plot the point, or do I plot the point and then sketch out the slope? Yeah, you always start off with your point first because you know that that point is actually on the line. If you just start counting off a slope, you won't really know where you're starting or stopping. It's going to be a mess. But if you start with your point, you'll at least know that that point's on the line. So I'm going to plot 0, negative 8. Can anybody describe what that means? 0, comma, negative 8.
You put a point on 0, comma 8.
Yeah, so, but you're right. I mean, we didn't go left to right at all. Why wouldn't we do that?
There was 0.
Yep, 0 left and right, and then he said straight down 8. That's right. So I go straight down 8. So that purple point down there towards the bottom of my graph, that point is actually on my line. Okay, so then the way that I get another point, or maybe a couple of other points, is I'm going to count off my slope. Where do I start counting my rise and my run? Where do I begin that? I'm looking for a location. At what location do I? Yeah, at that point that's on the line, right? And you said, Bree?
If it's negative or positive, you go this way for negative and this way for positive.
Yeah, that's kind of a nice check at the end, right? To see if we're going uphill or downhill?
Yeah.
Totally. We'll do that here in a second. So rise over run, 3 over 1. So what that means is, I'll put this in as like a blue dotted line. I'm going to rise 3. So I'm going to go up 1, 2, 3. And then I'm going to go right 1. And where that little dotted line ends, that would be where my second point on this line is. And maybe some of you have done this before. Can't you keep counting the slope off?
Yeah.
So I could keep going. I could go, starting there, I could go up 1, 2, 3, right 1, and I could put another point there. And I could just continue on for as long as I care to until I feel like, okay, yeah, this is definitely a line. How many points do you really need to finalize the graph of a line?
2.
You really only need 2. So if you just wanted to count off one slope, I'm okay with that. It might be wise to count off a couple of them to make sure that you're consistently counting and that it all makes sense. If you count off one of them, that's fine.
You can go down too, right?
You can. So this one we would run off the bottom of the graph. But if I did go down 3, because that would continue the pattern,
You go left.
I'd have to go left 1. Yep, to continue the pattern. So I'll sketch that out. We might not be able to see it that great here, but I would go down 1, 2, 3, right 1, and I don't know if you can even see this or not. Oh yeah, you kind of can, can't you? So that would be that reversing the direction of the slope. Once you've done this, we simply connect those points with as straight of a line as you can. And then what should go on the end of your line?
Arrows.
That's right. What do the arrows mean? Yep, just keeps on going, continues on forever in either direction. What do you think? Any questions? Okay, so then slope-intercept is a really popular form, but there's another form that I think should be, in all honesty, just as popular. And I think that's the one coming up next. So let's check that one out, and then, yes, we'll get a chance to finalize some practicing and go over your tests from last time. Okay, so let's review. What are the two things that I need
Point and slope.
to graph a line?
Slopes.
You said it. I need a point that's on the line and a slope. So slope-intercept form, as mentioned earlier, y equals mx plus b is a fine form to use. It works great. But it doesn't always work the greatest in every single situation. Because can you imagine, what if your y-intercept was like 4 3/7? Really not that convenient to count your slope from that y-intercept of 4 3/7, is it? How about 2.684? Again, awkward, right? So in some cases, maybe it's this one, maybe it's other ones. Another form might be better. Okay, so it's not, in no way am I saying, hey, let's just add stuff to their plate just to make it as difficult as possible. It's really a sense of sometimes this is going to be easier. A lot of times this is going to be easier. Sometimes slope-intercept will be easier. I want to give you more tools in your toolbox than just one. Have you ever heard the phrase, to a hammer, everything looks like a nail? To a hammer? What's the one thing a hammer's good for? Hitting things, right? So to a hammer, everything looks like a nail. I'd like to give you a screwdriver or a drill, another tool in the toolbox, right? Make sense? Okay, here we go. Sometimes you will have a different form, as outlined in our intro video. This other form is called point-slope form. This is not a very creative name. What two pieces of information do you think you could get from point-slope form? A point and a, right? It's not that creative. Just like slope-intercept is, you get the slope and the y-intercept. Point-slope, you get a point and the slope. So I'll write this down over here. I can't remember which letters I used in the video. Darn it. Did I use... Somebody help me out here. I want to make sure, I want to be consistent. Did I write, in the video, did I write y minus y sub 1 equals m times x minus x sub 1? Or did I write something different? Anybody remember?
I think
That's what I wrote? Okay. Okay, so this is official point-slope form. So one thing should look really familiar. What's the one letter that you look at and you're like, oh, I totally know what that is? M. The M is the same M. It's the slope. So as I look at this version of a line, what would you guys identify as the slope?
-1.5.
Yeah, isn't it right here? And see how those line up pretty nicely? They're in the same spot. So yeah, I would say my slope is -1/2. Therefore, my rise over run maybe could be -1/2 or 1/2. I can go either way there. And then this is where this one is just a touch tricky, and maybe you can kind of see the way the form is written up there. To find the point on the line, I got to be a little tricky with the x and the y coordinates. Anybody want to venture a guess what you think the point on our line is? What do you think, Bree?
4.
There's got to be an x and a y, right, on a point.
Uh-huh.
You got to have x comma y. So just saying 4, there should be something else in there.
0, 4.
0, 4. What do you guys think about that? Is that right? You agree, disagree, you're not sure? Where do we stand? What do you think, Sasha?
Is it 3, 4?
3, 4. What do y'all think about that? Okay, anybody have anything different? What do you think, Mason?
3, 4,
Yeah.
because the x-axis goes first.
Okay. Yeah, certainly the x goes first, right? X comma y. That's exactly right. I'm kind of wondering, Bree, the 0. Where did you get the 0 from?
Well, I forgot that.
Oh, you were thinking y-intercept.
Yeah.
Gotcha.
I think it's 3, 4.
Here's 3, 4. Okay, so now Bree does not think that it's this, so we'll get rid of that. Anybody have anything different besides 3, 4? Okay, well, 3, 4 is really close, but it's not right.
3, 4. Is it?
No, it's a good guess because you're thinking half of 4, maybe.
3, -3 over 2.
Okay, so is the negative coming from the -1/2?
Yeah.
Okay. So let me point something out. The 3, 4 was super close. Notice how, if you will, notice how this is y minus y1, like y minus a y coordinate, and this is x minus an x coordinate. right? It's specifically minus. It's not plus or something else. So when I look up here, y plus 4, how do I get y plus 4 if it's y minus something?
Because it was negative 4.
If it was a negative 4. And how do I get x plus 3 if it's x minus the x-coordinate?
Negative 3.
Yes. So the point on the line is negative 3, comma, negative 4. So a short way to think about this is if you're going from the point-slope form to get your actual point, what you're going to have to do is change the sign of the number to get it to be your actual point. Now once you have this, we're going to graph this much the same way we graphed the other line, right? So you guys think we should start counting off our slope first or graph the point first? We always graph the point before we graph the slope. That's right. So negative 3, negative 4. Bray, what on earth does that mean? If I have the point negative 3, negative 4, where do I go?
Over negative 3.
So left or right?
Left.
Left 3 and then?
Down negative 4.
Down 4. Yeah. Left 3, down 4. I agree. Good. Okay, so then that is a point that's for sure on the line. Now we're going to count off our slope. Doc, what do you think? My slope is...
Up 1, over 2.
So be more specific than over. Do you mean right or left?
Right.
Up 1. So I'll count this off like I did the other one. So I'm going to go up 1 from that point, right 2. So what do y'all think about that? Oh, I'm hearing no. Sophia, what do you think?
Isn't it left because it's negative 1/2 rather than positive?
Okay, so you're agreeing with the up 1, but you're saying we should go left 2. So you're saying we should go over to this other point, right about there. Okay, what do the rest of you think? So I do agree that we should go up 1, left 2. Because of the negative. And so I also wrote it over here. Check this out. I wrote my slope, my rise, and my run like that. Doesn't a rise of 1 doesn't mean go up 1? And then if your run is negative, that means go left. So it'd be up 1, left 2. So I'll get rid of this over here. Doc, let me give you a chance to redeem yourself. What if I wanted to go the other way? Like you brought it up, I think, on that other line. So instead of going up 1, left 2, I could do?
Down 1, right 2.
Nice, that's right. So I could go down 1, right 2, and I get to this other point. And you can see how that's the same linear pattern as the other two.
So you can do either one.
Yep, you can go either way. And you can go as far as you want. You know, whatever's convenient with the size of the graph, location of the points, and all that stuff. And of course, we want to connect these points as best we can with a straight line. Put arrows on the end of it, and there is my line. So, some common errors. Be really careful with your positivity or negativity of your slope. I'd like to bring up the thing that Bree mentioned a few minutes ago. When you're done graphing your line, like we're done now, I should be able to look at my line, and I should be able to, I might have messed this thing up a little bit, but I should be able to tell whether it's at least in the ballpark or not. And here's how you do it. This is what Bree brought up. If your slope is negative slope will always seem to go downhill from left to right. Negative slope, your line should be heading downhill as you read from left to right. A positive slope would appear to be uphill from left to right. So a positive slope would be just headed the other direction. So if you think about it like a hill from left to right, sometimes the negative slope, positive slope thing will help, right? Just a general idea of like, am I even close, right? So here's what I would do. Let's say I tried to graph this line, and let's say that I came up with this, that red line. I would look at that red line and say, okay, cool, my red line, it's going uphill from left to right. And then I'd look back at my slope and I'd say, oh man, but my slope is negative. If you need to use the restroom, you're welcome to it. My slope is negative, but my line's going up the hill. So I messed something up, right? So it's just kind of a nice way to back check yourself and make sure that it at least makes sense from that perspective. You're welcome to do that. Okay, so I would like to, this is going to work out really good, I think. Do you have any questions on this, by the way? I was looking around, reading faces. I feel like you need a little bit of practice. So I think that there are 2 more practices. here for us to do. And I for sure want you to do number 3. And we'll see about number 4. Okay? So if you would, take a look at number 3. You're going to get some bonus practice on this one. When you look at number 3, did you notice that it's not in slope-intercept form right now? It's not y equals mx plus b. So the first instructions here are to solve for y, to get it into slope-intercept form. So please take a minute and do that. I'll give you a solution on that, and then I'll have you guys try to graph it. So try to take that equation. Currently the y is not by itself. See if you can get the y by itself. So Oliver, I don't think you need to be looking back to that one, but at this point, I would just take that equation you have right there, the 3x minus 2y equals 8. See if you can get the y by itself. Solve for y. This is actually a worst step. This is equation solving. Yeah, that's great. We can divide by -2. I wouldn't do this all in one step. I feel like you're kind of cramming it all into one step. I would like your idea of subtracting 3x from both sides, dividing the money.
Are we just doing the
And then you get to that step that Anya has right there, and then you can see that it's -2 times y. So to get the y by itself, that's what we divide by. Yeah, so I think what I'm going to show you guys here in a second is like you can go division by 2 and then division by 2, or you can go division by 2, division by 2. And I'm going to favor that last one because that'll get you into that slope-intercept form better. So I would erase just this little middle part right there. And I would put division by -2, division by -2. That way you can simplify it. This is that form that I want you to get to. What you were about to do was not wrong. This will just be a better form. Yeah. You're dividing by -2. So it'd be positive 3/2x minus 1. Yeah, you showed really good steps. You divided the left side by -2 and the right side by 2. Okay, let's check this out as far as how you solve. This is an old skill. This is something we looked at a couple of weeks ago, and we've been practicing it a little bit ever since. 3x minus 2y equals 8. My goal is to get the y all by itself, so I'll be in slope-intercept form. Does anyone have a suggestion on what we could do to start getting that y by itself? What would you do starting off? Go ahead, Bree, say it.
I would subtract 3x.
Yeah. So let's do that. Subtract 3x. We want to move that whole term over to the right side. And some people are a little hesitant to do that because they say to themselves, yeah, but I can't subtract 3x from 8 because they're not like terms, right? And you're 100% correct. So what is 8 minus 3x? It's 8 minus 3x. Yeah, we don't get hung up on how do I combine them because you just can't. So don't get worried about that. We just write it for what it is. So then my next step is coming up next after Julia's question. Oh, what do you think we do?
When you divide by -2.
Yeah, divide by -2. Can I show you guys what I think is probably the best way to divide by -2? I think this is going to be the best way. I'm going to divide this side by -2 and then this side by -2, but I'm going to write it like that. Sorry, that's a little bit of a small writing there. I should maybe write a little bigger. Can you see how I divided every single term by -2?
Yes.
So similar to what we did in the past, this is where I want you to go because now we're going to be in slope-intercept form. Y equals, what is 8 over -2? -4. And then sometimes people will struggle with this. What's -3x over -2? But a negative divided by negative is? Positive. So Mason, you're not wrong. I just think I would convert that over to a plus 3/2 x. So let's identify our y-intercept and our slope, and I'll let you guys try to graph it from that. What would you guys say the slope is for this particular line? So it's really tempting. Check this out. I heard a couple different things. So it's really tempting to look at this. That's slope-intercept form. And can you see how someone would want to say that the slope is -4?
Yes.
Why is the slope not -4?
Because it's not with the x.
It doesn't
Yeah.
have an X.
It's the number with the x. So can you see how what we have in green up there is like the order is switched around?
Yes.
And so it's not the first number you come to, it's the number that's attached to the x. So the m is not -4. The m is actually,
3 over 2.
the m, is attached here, right? It's mx and 3/2 x. So 3 over 2 for my slope. And can anyone identify the y-intercept?
-4.
Now remember, points are never just a single number. 0, comma -4. Okay, so based on that, if you guys would, see if you can take that information and graph that line. And while you are doing that, I'm going to hand back your test. Please do not flip your test over and look at the front until after you've made an attempt to graph this line. Okay, so again, guys, listen up, please. Can I get your eyes up here, please? I know it's tempting to jump right into the test. We're going to do that here next, if you would. So, Issa, if you could just shut your test for a second. I know that's asking a lot. Give me 1 second here. Let's just make sure that you're good with graphing a line at this stage of the game. When I graph a line, I need a slope and a point. I've got them both. Which do I graph first, the point or to graph the slope? Graph the point first. 0, -4 is right there. And when I count off my slope, I go up 3, right 2. So my second point would be right about there. And then I would attempt to connect those with as straight of a line as I can. About like that. Get arrows on the end. That would be my line. How are we doing? Is that okay?
Yes.
All right, fair enough. So what I would like to finish with you guys today is an opportunity for you to ask any questions you want on your test. So let me close this guy up here.